electric energy generation using solar energy. Using solar energy in the sunlight, electric energy can be generated in two ways. In all the above methods of electricity generation we have studied, the electric generator is driven by some source of energy and electricity is generated by making use of the principle of electromagnetic induction. However, the electrical energy can be generated directly from solar radiation without usage of the generator and without using the principle of electromagnetic induction. This happens in solar photovoltaic cell. Solar photovoltaic cells can convert solar energy directly into electrical energy. In the second method, the energy in the solar radiation is converted into thermal energy first. Then a turbine generator system is driven using that thermal energy to generate electricity. So first type of solar electricity is solar photovoltaic cell. Solar photovoltaic cell can convert solar radiation directly into electrical energy. Solar radiation energy directly into electrical energy. This is called solar photovoltaic cell or solar photovoltaic effect. The electrical energy generated through this energy transformation process is DC in nature. DC is direct current. The solar cells are made up of special type of material called semiconductor, for example silicon. A silicon solar cell of dimension 1 square centimeter can generate about 30 milliampere and a potential difference of about 0.5 volt. Thus, a silicon solar cell of dimensions 100 square centimeter will generate about 3 ampere and 0.5 volt. Remember that the potential difference available from a solar cell is independent of its area. So, energy in the sunlight can directly be converted into DC electric power using photovoltaic effect. If two solar cells are connected in series as shown in figure 5.23, the potential difference obtained from this combination is addition of the potential differences of individual solar cells. So, series combination will give you addition of the potential differences, summation of potential differences. However, current generated from the combination is equal to the current of individual cells. That means when solar cells are connected in series, currents are not added, the potential differences are added. Similarly, if the two solar cells are connected in parallel, then the current generated from the combination is the summation of the currents of individual cells. However, the potential difference in the parallel combination remains the same. Thus, if two solar cells are connected in parallel, the potential difference is not added, but the currents are added. In this way, by connecting many solar cells in series and parallel, solar panels generating required current and potential difference are made. In figure 5.25, for example, if 36 solar cells, each of area 100 square centimeter, are connected in series in a solar panel, it will give you a potential difference of 18 volts and 3 amperes. Many such panels are connected together to generate electricity on larger scale. A good solar cell has efficiency of 15%. That means if 100 watt solar radiation falls on it, it can convert 15 watt out of that into the electrical energy. Many solar panels are connected in series and parallel to generate required current and potential difference. As shown in the figure, solar cell is the basic unit in solar electric plant. Many solar cells come together to form a solar panel Many solar panels are connected in series to form solar strings, and many solar strings are connected in parallel to form a solar array. As we can obtain as much of electrical power as needed, they are used in applications which need marginal power, like calculators, to big power stations having a capacity of megawatts. The power available from the solar cell is DC. So in applications which need DC power, for example, the LED lamps, the energy can directly be used. However, since energy from solar cell is available only in presence of sunlight, the energy has to be stored in batteries for use at a later time. However, most of the equipment in domestic as well as industrial use run on AC power. In such case, DC solar power must be converted to AC power using an electronic device called inverter. So inverter converts the DC power into AC power. We have seen that many solar panels can be connected together to generate whatever energy we need. As shown in figure 5.28, the DC power generated from this panel is first converted into AC power. A transformer transforms the voltage and current level of the generated power, and then it is fed to the electricity distribution network. Then figure 5.28 shows you a schematic of a solar power station. In this way, electricity is generated without any fuel combustion and so without any air pollution. However, since the energy is generated using solar radiation, it can only be generated during daytime. Solar thermal power plant. We have seen that thermal energy generated from coal and nuclear fuel can be used to generate electricity. Thermal energy can also be generated from solar radiations and can be used for the electricity production. Different stages in such solar thermal power plant are as shown: concentrators for collecting sunlight, absorber of absorbing the concentrated sunlight, steam turbine, electric generator, and electric energy. As shown in figure 5.30, many reflectors reflect and concentrate solar radiation on absorbers. Their solar energy is converted into heat energy. Using this heat energy, steam is generated which can drive the turbine and the generator. Here you can see there is a concave reflector which concentrates solar energy on the pipe. The water flows in the pipe, is boiled and converted into steam, and then the steam runs the turbine runs the generator. In world, 41% energy is made from coal, India 60%. Natural gas, world percentage 22, Indian percentage 8. Hydroelectric, world percentage 16, Indian percentage 14. Nuclear energy, world percentage 11, Indian percentage 2. Petroleum 4 and 0.3. Renewable sources, world average is 6 and Indian is 15.7.